Okay, now we're going to look at number 15 from our homework. So number 15 says a 70-kilogram astronaut, so I'm going to write my given, is standing on a spaceship while the ship is moving in a straight line with a constant velocity. Now, let me write the constant velocity. The velocity is 100 meters per second, and it's constant. Whenever I see the word constant velocity, whenever I'm doing a problem, I'm going to write down that word constant velocity. Why am I going to write down constant velocity? I'm going to write down constant velocity because that means the acceleration is 0, and that's really, 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 really important. So now it says the scale reads 300 newtons. Well, the reading on a scale, let's think about that. The reading on a scale is what? The weight, right? Like when you stand on a scale, that tells you how much you weigh. So the reading on the scale is actually equal to what? mg. So that's equal to 300 newtons. So now it says the ship then accelerates away from the planet at 7 meters per second squared. So now my acceleration is going to be 7 meters per second squared. So all this information is important, but then he starts to accelerate. What does the scale read now? So now I want to find the scale reading. But this is when it accelerates. So I can draw my free body diagram as a box. This represents my astronaut. And when he's accelerating, I'm going to have the weight down, which is mg, but then I'm going to have a reading up, and this is an upward acceleration. I'm just kind of drawing it to the side so I see what's happening. We have to establish our sign convention. Remember, you cannot do these problems unless you have your sign convention. All right, so first I'm going to draw my sign convention. Up is positive. Then I'm going to apply Newton's second law in that direction. So I'm going to say summation of F net is equal to ma. Now, once it accelerates, is this object accelerating up? Yeah, they told me it's accelerating at what? 7 meters per second squared, right? Now, what are the forces that are going in this y direction? Well, I have the reading on the scale, which is up, right? Minus the weight. And that's going to be equal to ma because it's accelerating. And remember, the 7 meters per second squared, that's this acceleration here. Remember, this F net, this replaces, this shows all my forces going in the y direction. Remember, the sign is important, and that's going to be equal to mass times acceleration. Now, since I want to solve for F scale, I'm going to rearrange my equation to solve for the unknown in terms of the known. So I'm going to leave the F scale where it is on the left side of the equal sign. And then I'm going to leave the ma where it is. But what I'm going to do is I'm going to move this to the other side. So I'm going to say like plus mg plus mg. So F scale is equal to ma plus mg. So F scale is equal to the mass. Oh, they already gave me the mass, 70 kilograms. times my upward acceleration, which is 7 meters per second squared, plus mg. Oh, they already told me mg, which is 300. So you know what? You don't even need, I didn't read the end of this problem. This 100 meters per second, you don't even need that. You don't even need this in this problem. Because when it's moving with a constant velocity, the acceleration is 0, but they already gave us this weight. So we don't even need that in the problem. So now what I do is I add all this up, and that gives me F scale is equal to 790 newtons. Because 7 times 7 is 49, but that has a 0, so that's 490 plus 300 is 790. And that's why, even though you have a calculator when you're doing your homework and on the test, you see how I could still do the math in my head to check it, you know, and say that's 490 plus 300, just to make sure I didn't make a mistake pressing on my calculator, okay?